Hi, I'm Peter. In this video, I'll show you where a computer gets its local IP address from. Now, usually something called the Dynamic Host Configuration Protocol will automatically take care of that for you. It hasn't always been this way though. Let's have a look at a world before DHCP was invented. In our example network, every host will have an address that starts with 192.168.1. At the center of our network, we have a router that is wired up to two hosts. A common way to assign addresses would be to give our router the .1 address and to give the host the .2 and .3 addresses respectively. If someone accidentally gave the same IP address to both computers, we'd have an IP conflict on our hands. Now, I don't know if you've ever shared a street address with another house, but that's bound to lead to all sorts of misunderstandings. Granted, that's still a small, manageable network, but what about 4 laptops? Maybe throw in a couple of smartphones, add a tablet phone hybrid, a smart TV to watch YouTube on, a Wi-Fi enabled printer, and a washing machine that sends a notification to your phone when the laundry is ready? Oh, don't give me that weird look, it's inevitable. Look, I don't invent these things, but this is a mess and we need a system. Instead of keeping track of all those IP addresses manually, why not let DHCP do all the math for you? Before we cover the technicalities of the algorithm, here's the simpler bird's eye view. Jumping back to the previous example, the second computer has just joined the network. At this point, it doesn't have an IP address, but it wants one. First, our new host will send a message asking for an IP address. The router will respond to this request with an offer. The new host will accept the offer, and finally, the router will confirm that the IP address is now assigned to the host. From this point forward, it is known as 192.168.1.3. Now that you get the gist of it, it's time to look at DHCP's 4-step process in a little more detail. DHCP has 2 requirements, one of which being a server. You'll need at least one DHCP server on your network, but routers usually have one built in. Secondly, every host on the network needs to run a DHCP client. There are ways to run DHCP alongside static IP addresses in your network, but let's not overcomplicate things right now and leave that aside. Here's our trusty old network again. We have a router set up at .1 and we have a host set up at .2. Let's consider what happens when a new host appears. Step 1 of the process is the DHCP discover step. This is where the host searches for any available DHCP servers to get an address from. Since the host does not know where our DHCP server is, it will just send out a discover request to everyone on the network. This is called broadcasting. To put it in human language, the new machine asked everyone for an address. Since our new host does not yet have an IP address, the sender field of this packet will be set to 0. The receiver field will be set to 4 times 255, which will cause the packet to be broadcast over the current network. One last thing about ports before we move on. UDP port 68 is reserved for DHCP clients. UDP port 67, on the other hand, is reserved for DHCP servers. Step 2 involves the servers offering an IP address to the new host. The way they do this is by broadcasting their offer to everyone on the current network. The reason that they broadcast this information to everyone is that they don't know where to find the new host. A typical DHCP offer message will say something like, "I'm willing to give you this address for that amount of time." The sender will be the DHCP server, and the receiver will again be the broadcast address. Note how the ports were flipped, so the sender is the UDP port 67, which is the server port, and the receiver is port 68, which is the client port. Moving on to step number 3. At this point, the host has received at least one offer for an address, and it now gets to pick which one it wants. After having done so, it will send out a DHCP request message to everyone on the network. Once again, this is a broadcast. And in this message, it will say which address it picked. With this DHCP request message, the host expresses its intention to accept a specific offer. In this specific example, the host wants to claim 192.168.1.3 for 3,600 seconds, which of course is equal to 1 hour. Once again, the sender field says 0 because we don't have an address yet. You should also take note of the ports that are used here. We're doing 68 to 67, which is client to server. We're down to the fourth and final step now. This one's called DHCP ACK, where the ACK stands for acknowledgement. In this step, the DHCP server will confirm to the host that it can start using the address. Like in all other steps, this message will also be broadcast. Loosely speaking, a DHCP ACK message will confirm that the host can start using the address for the previously specified amount of time. As is the case with DHCP offer messages, the server will put its IP address into the sender field and use ports 67 and 68 as the sender and receiver. After the host receives confirmation, the process is complete. Now the host can start using its shiny new IP address. Now, before we wrap up, there are a few more things you might want to know about. As I said earlier, you need at least one DHCP server on your network, but you can also have multiple. When you have multiple servers, they can all respond with an address offer. Whenever this happens, the new host will be allowed to choose from any of the offers it received. It will announce its choice using a DHCP request message, like we saw in step 3. There's always the possibility that two new hosts start asking for IP addresses simultaneously. So, how can we keep them apart? The answer is relatively simple. DHCP uses transaction IDs to keep track of ongoing procedures and to distinguish them from one another. You may remember that addresses expire after a certain amount of time. Well, that mechanism was invented to recycle unused IP addresses so that others can use them again. Hosts can prevent the server from taking away their IP address by renewing the lease. We won't cover that procedure here, but just remember that this is the reason why your computer's IP address doesn't suddenly change for no apparent reason. Alright, that's it for DHCP. If there's anything you'd like to see explained here, let me know in the comments. Thanks for watching, see you next time.